Hello everyone, welcome back to my channel. So today we are going to see an advanced C++ technique known as perfect forwarding using templates. So perfect forwarding is a powerful concept in C++ that allows us to maintain the original value category of our arguments during the function call. So it's crucial for writing efficient and flexible code. It seems to be a bit complicated, this definition, so don't worry, we will be seeing a perfect code example for that. So stay with me throughout this video. So what is perfect forwarding? So perfect forwarding is a technique in C++ that allows us to forward both L values and R values to functions while preserving their original value category. So what are L values and R values? So L values is kind of a value which has an address. So if you see this particular thing, this is an L value reference. And if you see this particular function parameter, this is an R value reference. So these are two kinds of values which you can have. So this ensures that when we forward an argument to another function, the receiving function can distinguish between the L values and R values, leading to more efficient and flexible code. So to achieve perfect forwarding, we need to understand the universal reference. These are special references introduced with C++11 and which is denoted by a template parameter and a double ampersand sign. Therefore, this is known as a universal reference. So universal reference looks similar to R value. If you just see this particular thing, it might look similar to the R value reference which is there, but they behave totally differently. They are a combination of an R value reference and a template type detection. So when we use a universal reference as a function parameter, the type detection rules allows us to capture both L values and R values. This is a key aspect of achieving perfect forwarding. So now let's try to see the code. So how this particular piece of code is there. So if you see, I have created a main function with an L value, which is a variable, and it is being passed to a forwarder function with that particular variable being passed as an L value reference, which can be referred here. So again, I'm calling the same function with a constant value. Therefore, this particular value will be passed as an R value reference. So this particular, uh, the compiler will look for a matching function definition for this particular forwarder function where we are passing a R value reference. So if you see, I have defined this forwarder function like this. As I already mentioned, this is a universal reference type. It is able to accept both L values and well as R values. And once it receives this particular thing, we are calling the process function with an std forward function, passing in the argument which we got. But talking about the significance of std forward, so it's a utility provided by the C++ standard library that plays a crucial role in perfect forwarding. Therefore, this is you can say it's the star of the show, this std forward. What this does is when we use this std forward, it ensures that the original value category of the argument is preserved. This means if we receive an L value here, we forward it as an L value to the function. If it is we are receiving an R value here, we will forward that particular uh, argument as an R value only to this particular function. So that's the significance of std forward. This is the main star of the show. So if you just see, as I have called this particular function, therefore accordingly it will discover whether to call this particular function this using an L value argument or call this particular function with an R value argument. So let's try to run this particular piece of code to see what happens. As you can see, the L value reference, L value processing, the process function for the L value is called for this 42, which is an L value in the main function as well. And the R value processing, which is printed by this particular function, which is for this constant value 123, which is an R value which is being used in the main function. If as you can see, the correct process overload function is being called from the main function if we use a std forward with a universal reference operator. So that's mainly I want to cover in this video. There are some other advanced things like limitations of this particular universal reference or the perfect forwarding thing and what all in which all scenarios you can use this particular thing that I will plan to cover in the next video. So until then, you can just try out this particular L value as well as R value in your application to see how this particular code functions. So thank you all for joining us today. If you found this video helpful, don't forget to give it a thumbs up, subscribe to the channel for more C++ content, and hit the notification bell to stay updated. So please do check the description box below for the links to the bit of, for the blogs that I have written related to the other technical concepts as well. So please feel free to share your experience with perfect forwarding or any questions you may have in this comment section below. I would be love hearing from you guys. That was